Welcome to Leaving Cert Plus. This is lesson 1.3 and this is Factorising Algebra. First of all, what is Factorising Algebra? This is where we put the piece of algebra back into brackets. It's the opposite of lesson 1.1 where we had to multiply out brackets. There are three main types of factorising questions. The first one is known as highest common factor, HCF. And in this particular example, you would have to try and find something that's common between the 3x squared and the minus 12x. If highest common factor doesn't work and you see perfect square numbers such as 4, 16, 25, 36, 49 involved, it's more than likely a difference two squares question. And finally, if there are three terms and the first term involves an x squared and the second term involves an x and the third term is a number, it's more than likely a quadratic. Solving a quadratic equation is very commonly asked, but in this particular lesson, we're just going to learn how to put them back into brackets. So let's begin. The way this is going to work is I'm going to do two parts of each type. So two parts on highest common factor, and then you're going to try the next two. So pay attention and we'll see how we go. So in this first part, we have to take out something that's common between x squared and minus 4x. So I'm thinking that x is common. Then we have to open a bracket and try and see, can we decide what x would multiply by to get x squared? So in this case, it would be another x. And then what would x multiply by to give minus 4x? And that would be minus 4. If you want to check that it's right, you don't have to do it, but if you want to check that it's right in your head, if you multiply out x by x and then x by minus 4, it should go back up to give you what you started with, and it will. So that means you've done it right. So in our second example, we're going to take out something that a little more common than just x. It's going to be 2x. Why? Because 2 goes into both 2x squared and 10, and then x goes into 2x squared and 10x as well. So then what would 2x multiply by to give 2x squared? It would be an x. And what would 2x multiply by to give 10x? It would be plus 5. And we're done. So now it's on to your two examples of highest common factor questions. Pause the video, have a go, and come back to me in a moment. So how do we do? The first thing we would have done is taken out our highest common factor. In our first question, it would have been 5x, and this would have left behind x minus 4. In our second example, it would have been 7x, and that would have left behind x plus 2. On to our second type and a difference two squares question. In these particular examples, you'll notice that HCF doesn't work. There's nothing common we can take out for x squared and 36 or 4x squared and 9. So what we're going to do in these questions is set up two squares. Two squares look like this. It's something squared and something squared. What goes into these brackets is the square root of x squared, which is x, and the square root of 36, which is 6. Your final answer then is always the first one plus the second one, and the first one minus the second one, and you are done. In our second example, same idea, set up our two squares. So the square root of 4x squared is 2x, and the square root of 9 is 3. Our final answer will be 2x plus our 3 and 2x minus our 3, and there we have it. We've just factorised two difference of two squares questions. Now it's your two. Pause the video, have a go, and come back to me in a moment. So how do we do? The first thing we would have done is set up our two squares, and then we have our easy solution of the first plus the second and the first minus the second. In our second example, it would have been 3x to be squared and then 10 to be squared, and again, easy solution, 3x plus 10 and 3x minus 10. Okay, on to our trickiest type, and these are known as quadratics. The first thing we do with quadratics is we set up two brackets as so. What goes into the front of these brackets is two terms that multiply to give x squared, which is usually x and x. Then we have to think of, for the back of these brackets, of two numbers that will multiply to give plus 12, but they also have to add to give the middle, which is plus 7. So think about it. We could go with 6 and 2, but obviously 6 multiplied by 2 does give plus 12, but it adds to give 8, or 6 take away 2, it will give you 4. So it doesn't give us 7. So now we're thinking of maybe 3 and 4. So 3 and 4, yes, they multiply to give plus 12, and they add to give plus 7 if you have both of them being a plus. And there we have it. So remember, it has to do two jobs. The numbers 3 and 4 have to multiply to give plus 12 and add to give plus 7. Let's try a slightly harder example. So open our two brackets, x and x at the front, and then we want two numbers that will multiply to give minus 5 and add to give minus 4. Now, thinking about this then, 5 is an easy enough number because it's going to have to be 5 and 1. There are no other factors of 5, so 5 and 1. But then signs-wise, we have to get these two numbers to add to give -4, so it's going to have to be a minus with the 5 and a plus with the 1. Let's check it out one more time. -5 by 1 gives -5, yes. And then -5 plus 1 gives -4, yes. It fills both criteria, which means we are correct. Okay, last two questions of the day then. These are your two, so if you want to pause the video, have a go, and come back to me in a moment. Okay, I'm going to do these out for you because these are really tricky. So first of all, x by x. So the two numbers that multiply to give +30, you could go with, say, 15 and 2, but that will give 17, or it'll give 13. No, we're thinking of 6 and 5. 6 and 5, they will multiply to give 30, and if you give them both pluses, they will also add to give 11. So there is your first answer, x plus 6 and x plus 5. In our second example, if we open our brackets and x is the front as per normal, we now look for two numbers that multiply to give +16. So +16, if you went with 4 by 4, but 4 by 4, they will multiply to give +16, but will only add to give 8, so that's not going to work. So we're thinking 8 and 2, so 8 and 2 again. And then multiply to give +16, but we have to get them to add to give -10, so it's going to have to be two negatives. Both of these, -8 by -2, does give +16, and they add to give -10, so we are correct. Just be aware that factorizing algebra does not come up too often. What comes up more often is using these particular methods in solving an equation. I hope you found this video interesting. Join me again on Leaving Cert Plus.
If you like this video, you'll love our notes. You can get some for free in the link in the description of this video.